So, there's so we are very happy to have the August community meeting for WasmEdge. We have some, I think, very interesting demonstrations with AI and lots of new progress. So without further ado, let's get to our first demo. So people have always asked, oh, why do I use WasmEdge for AI inference? Why can't I just use llama.cpp? Why do I need an extra layer of indirection? And why do I need a LlamaEdge? So if you just want an API server to do inference on the Llama model, for instance, why can't I just use OLlama? Why can't I just use llama.cpp? And the answer has always been, the extra layer of Wasm abstraction not only gives you portability across different hardware, so you don't have to be tied. You just write your application once. It can run on the Mac, can run on NVIDIA. You don't need to change anything. You don't even need to recompile it for CUDA or for Metal. But perhaps even more interesting is that it gives you cross-model capabilities. So meaning that you can not just run the large language model or that large language class of models. You can also run something entirely different. For instance, to generate images, right? To generate voice or to recognize voice. We have done some of those demos in the past, but today, I think we have just released, I think the first build of the of the LlamaEdge runtime for the Stable Diffusion model, right? So currently it only runs on CPU. That's why we're still working on ways to make it run on GPU. But when we want to use this opportunity, this first slot in our community meeting, ask George to come online and give us a demo of how how the Stable Diffusion model works in the WasmEdge LlamaEdge environment. Please, George.
Hi, can you see a screen?
Yes, great. Thanks.
Hi, I'm Tang. Today I will introduce the Stable Diffusion plugin. This is today's outline. In the beginning, I will run a simple example to show how to call Stable Diffusion plugin in Rust. Next, I will introduce our Stable Diffusion Rust SDK, and then introduce our Stable Diffusion plugin. Stable Diffusion is a text-to-image model. Our plugin is based on StableDiffusion.cpp, which is an influence of Stable Diffusion in pure C and C++. However, this plugin is still developing. Some functions have not been tested and implemented. But basically, every feature in the Stable Diffusion.cpp, you can do it with our plugin in the future. This is our WasmEdge Stable Diffusion repository. Today's example and the Rust SDK are all can be found in the repo. Before running the example, there are some preparation that need to be done. In the first, you need to build WasmEdge with Stable Diffusion. You can follow the command to install WasmEdge. Then download the Stable Diffusion model. In the repo, you can choose the quantized model, or you can download CKPT weight to quantize by yourself. Then follow the command build and run the Wasm. Can you see the terminal? You can use the following command, then it is start running. It is convert model on CKPT to GGUF model, but it needs some time, so we continue to introduce our plugin. In the example, you can see there are four structures: quantized, Stable Diffusion, and text-to-image, image-to-image. We can use quantization to create a quantized instance, and then use convert function to convert the CKPT to quantized model, to GGUF model. The first parameter is weight name, and the second parameter is the quantized GGUF name. And then the third parameter is the weight type that you want to quantize. The Stable Diffusion currently supports float 32, float 60, and 4-bit, 5-bit, and 8-bit model. I download the CKPT weight, so I will convert function to quantize my model. But if you download the GGUF, you can directly run the image-to-image and text-to-image. In the next step, we will use Stable Diffusion new context. The first parameter is the text type. You can use text-to-image or image-to-image. The second parameter is the Stable Diffusion model name. And for we can call create context to initialize the context. In our demo code, we create a text-to-image context based on our prompt to generate an image stored in output.png. And finally, based to the output image, we use image-to-image to generate another image that is stored in output2.png. The first image should be a beautiful sunset because we set a prompt. And the second image is a beautiful sunset and with a dog is running. Besides to generate an image, you can set some parameter to adjust the result. In the current state, you can say weight or height to adjust generate image weight and height. In the future, you can set more detail in the Stable Diffusion plugin. Next, let's change to WasmEdge Stable Diffusion plugin. Our plugin provides four functions. First, create context, image to image, text to image, and convert. If you call create context, then it will return a session ID. An image to image function and the text to image function, you need give it a session ID and a prompt. If you call text to image, you need give it another image. It will based on the image to generate a new image. Then image to image and the text to image will return PNG file back. If you set output parameter in the image to image or text to image, then it will directly store the PNG file in your computer. There are some other features we want to finish. We want to add some function to set Stable Diffusion plugin parameter in our ROS SDK. Although they are finished in the WasmEdge plugin. So if you set it in your roster DK, then it may work. And we want to support ESRG-AN to upscale. Then we want to support QDA and other accelerate library. But in current state, it only supports CPU to compute. So it may need a long time to generate image. It is it is current result. It's still running. In my computer, it need maybe 12 minutes. So I think we have no time to wait it finish. But before demo, I have generated an image. That is the result. The first image is a beautiful sunset, and the second image is a beautiful sunset with a dog is running. Then that is our demo. Thank you.
All right. Yes. Thank you. So, I think it's that highlights the importance, of getting running on GPU, I guess, because yeah, CPU, for this type of task is pretty slow. But as everyone can see here, that's we're pretty close. We are not, we already got it running. It's just getting new GPU drivers. And as I said, one of the interesting aspect of WasmEdge and LlamaEdge is that your application does not need to even recompile. When we have the GPU support on different platforms, you just install the correct version of the WasmEdge plugin on your platform, and the compiled Wasm application would just work. There would not even be the need to even recompile, right? So that's actually goes. I think it's far better than most of the cross-platform libraries out there where because think about it, you're crossing from one GPU architecture to another GPU architecture, that's I hope that's we'll get to the point where it's run on GPU really soon. Anyway, so if you have questions, you can just ask in the chat, or we can leave all the questions towards the end of the talk. Okay. So the next demo is actually mine, and it's let me try to share my screen. I'll share it twice. So here, let me share the documentation screen first. Okay, all right. So as you can see, we have a new article or new guide in our LlamaEdge documentation section, and it's about calling external tools, which I think is one of the most interesting use cases for large language model. Large language model, of course, you can chat with it, but I think chatbot only goes so far, right? You can only do so much with chatbot. And if people talk about AI native application, a lot of them are actually talking about tool calling, meaning that's you are not only chatting with the AI, but the AI is not only do the thinking and the talking, but it's also do the decision and then have direct effect on its decision. So it will decide to do something and then do it, right? Instead of chatting with you, a person chatting with it, then the AI tell you to do something, and then the person may or may not decide to do it, right? So this allows large language models to perform direct actions, and OpenAI actually has it for some time now, right? So if you ask ChatGPT something, it may decide to search the internet, right? To trigger some web service and get the result back. And so but on the open source side, because in the past the models has been mostly focused on improving the conversation experience. So not a lot of models are focused on, being fine-tuned to perform, tool calling. But things are changing very fast. And we now have, with the Llama 3.1, we now have, several great models that can do tool calling. So that's where we write this document, to show you how to use the large language model to control other tools and applications on your own computer, right? One of the use cases that we see from hackathon that we see, is that you may have a drone, and then or a small vehicle or car, something like that. That can it can be remote controlled. So you use the large language model and you tell the large language model what you want this vehicle to do, right? For instance, you can say, I want the car to go to that wall and take a look at what's behind it. So the large language model would be able to translate this instruction into function calls in Python programs and things like that, and send that to the vehicle so that it's instructed to go forward, certain amount of distance and then turn and then take a picture and then come back, right? So there are lots of very interesting use cases that they can do once you connect the large language model to the real world, right? So if you look at so this document, it pretty much goes through the process of downloading a model. Here is the Llama 3 model, but fine-tuned by Grok. So the goal of this fine-tuning is to make it more, to learn about what tools are available it can use, and then based on the conversation context, generate instructions on how to use the tool in order to follow up, in order to move forward with the conversation, right? Then you can use the WasmEdge and LlamaEdge API server to start this model, and then you can use a demo agent, which is what I'm going to show you right now. So this application is available at second state slash LLM to do. It's a to-do list application. Interestingly, I think most of the application today are we no longer do Hello World anymore because Hello World is too simple, right? So most of the applications you see today are to-do applications. It's a way to demonstrate that everything works, right? So the setup I have here is that I have a Python program here. It's called main.py. And the Python program starts a embedded database. So it start my SQLite database all on my own computer. And then it allows me to chat with it. Whenever I say something, it sends that everything I say to a remote server that runs the LlamaEdge model that I've just shown you, the Llama 3 Grok model. And it's running on a remote machine that is, half a world, a long way from me, right? And the model would process what I said and then come back with the tools that's available to it. So I already told what tools available to it in the system prompt, right? So it would detect, what tools it should use. And then the Python program, when it sees the tool use instruction, it will immediately perform the tool call, as we will see, and then get the results, automatically send the result back to the large language model, remote large language model. And the large language model would then go on and send us, a response. So let's see how it works. I think this demo is actually quite interesting. So Python 3 main pipe. So it just go on and say, it's a chat interface. User asks me to say something, right? Say I would like to write a README doc for my project tomorrow. Okay. So I send it. This is the okay. So the chat model actually because it knows its job is to create a to-do list. So it asks me, is there any details I want to include with the README doc? Yeah. Yes. I would like to include software installation instructions in the README doc. Okay. It goes back to the large language model and see what it says. I, I will restart the conversation. That's it's I think it's get to the point endlessly asking me these questions. I want to write a README doc tomorrow. Okay, so let's start over again. That's to give it. Would you like to create a task for you to remind you about writing the README doc tomorrow? So now it knows it needs to do the tool call. So I say yes. Okay. See here, instead of returning, the system didn't return a human readable, words. It just returns a structured data. It's called tool call. It's the name of the function. It's create task. Arguments is task, right? The README doc, right? So it gives back a machine readable response. The large language model didn't generate natural language. It generates a machine. It generates a JSON that instruct the client to do some action. So tool here is so the Python program sees this. It knows it needs to call the create task function, which is the Python function, and pass the argument, write a README doc into that function. What that function does is that to create a SQL statement to update the SQLite database locally to put that to-do item in there. So, and once the tool has done that successfully, it's going to return results, result okay. And the Python program, without my intervention, would send this result back to the large language model. Large language model knows that its tool call response has been handled. So it says the task to write a README has been created for tomorrow. Is there anything I can assist you with? I would also like to discuss a salary increase with my boss this week. Okay. So I tell the large language model that there's another item that I want to do, right? So do you want me to add the task as well? It's a little verbose. So I say yes. So what it does, I believe it's gonna send another tool call response back, which triggers the Python application to handle it. And it's again gonna call create task and with argument discuss salary increase with boss and update that into the SQLite database locally. So now the task to discuss salary increase with boss has been added. Any other task or request? I need to file a TPS report before talking to the boss. Okay, so I added another task that has a relationship with the previous task, right? Let's see what the machine says. So it doesn't ask me, say, do you want to add it or not? Now it says, the task is file TPS report. So it has a create task and then it goes back, right? So it says, the system says the task to file TPS reports has been created. Is there anything else I can agree with? I say, show me all my to-do items. So the large language model doesn't know what my to-do item is because it's stateless, remember, right? So what it does is that it's going to return a tool call that asks the Python program to look up the database and see what's the to-do items are, right? So you can see it's no longer the function is not create tasks. The function become get tasks, and there's no arguments. So the Python program queries the database and then gets results. Say result okay and tasks it's back an array. That's ID1, write a document, ID2, discuss salary, ID3, file the TPS report. So it sends this JSON structure back to the large language model. The large language model would be understand it and then to be able to formulate an answer, because it sees the result from the tool call. Now it says, here are your current tasks. So there are three, there's write documents, discuss salary with boss, file TPS reports. Now I say, I believe I have already, because I forgot, filed the TPS report. Okay. See if understand this, the request I'm implicitly making in this in this query, right? So in this query, it's successfully find out that I said I'm done this thing. So it's no longer a create task or it's no longer a get tasks. It's to update an existing task, and it knows that's the ID is free and the status is done. Okay, so the status of your TPS report has been upgraded done. Is there anything I can help you with? So So you see, it knows that with this sentence or with this request, I'm implicitly asking to update the status of the to-do item. So it records, it turns around and generates a tool call called update task. And update task is a Python function this Python client application knows. So it invokes this function and with the parameter that's it's given, right? So now I can do it again to say show me all my pending. Okay, so I believe it's gonna generate another tool call and get tasks, right? So it generates a tool call and then it queries the database again, and you can see the Python program returns all the three tasks. But the two of them has the status. Those all come from database, right? Because they originally all have the to-do status. So now the last one, because we update the task in the last one become done. So now it's smart enough to figure out the three tasks included in this JSON, which formulates the natural language to tell me that there's two current pending tasks because there are three tasks, one is done, right? So there are only two pending. The pending is write a README doc and discuss salary increase with the boss, right? So this goes on. That's you can actually do a lot more. Like I said, you can have it send an email from your computer, for instance. You can have it set alarm. You can have it, to a robot to go do something, fetch a beer, something like that. So there are lots of things that you can potentially do by combining the tool with natural language that describes your intention, right? So, I believe this is something that's very interesting, and there could be a lot of use cases, especially on edge devices, and to combine hardware with large language model, and to combine, so that the bot or the device can really understand human intentions and generate the appropriate actions, not generate the appropriate verbal response. That would help, help us do a lot better. Anyway, so that's my demo. So. Again, if you have any questions, you can go and ask at the end or in the chat area. So the next talk and the last from this community meeting, which I think is why a lot of you guys, that's why you are here, is for our maintainer Haidai to talk about the upcoming LFX mentorship. So we have I believe 4 mentorship opportunities, and I think all of them are super exciting. So Haidai, please.
Sure. Hello. Let me share the screen first. Here we go. Can you guys see my screen now?
Yes, it looks great. Yeah.
Okay, great. So before we start to talk about our mentorship, I have something to announce. That is, if you go through the some program rules or guideline, and one of the biggest thing is that according to this communication section, if you have any question or issue, if is related to the mentorship platform or website, you should contact the LFX mentorship support team. And if you have some CNCF related questions, you should ask in this discussion board. And if the question cannot be asked publicly, you should use this email to write your question, right? Most of the important thing is that we discourage and almost we had somebody directly send message to us because it will be very annoying, and this is also show in the communication section. So before you send any private message to us, just keep in mind, okay? And we do have this announcement, so I'm not sure why some applicants still try to direct a message to us, but please don't do that because we the only thing we will do is to ignore you. Yeah, so that's the very first thing I want to talk about. And if you have any question related to the to this full proposal, you can just ask your question under this full proposal, and we will if your question is there, and we will reply you. You don't have to do any direct messaging to us. Yeah. So back to our mentorship, and we have 4 topics. The 4 topics this mentorship, and this is the first 4. So let's go through each one. So the first one is that we would like to enhance our Wasm serializer because we do have previous mentorship, and that mentorship is provide a Wasm serializer in CAPI level. So it will allow you to convert the loaded Wasm structure, especially already, represent in the WasmEdge C or WasmEdge internal format. However, in some situation, we have to rewrite or to convert the internal data structure back to the Wasm binary format. That's why we call it the Wasm module serializer, because it is, convert a data structure back to the Wasm binary format. However, because the Menti implement this feature already, but after his, implementation, we support more and more new Wasm proposals, including the function references, including the Wasm GC, including the Redux SIMD, and the exception handling. So there are some new Wasm instructions are added into the the whole project. So that's why the current serializer will not work when your the loaded Wasm binary contains these new proposals. So this goal of this mentorship, this project idea, is to extend the original serializer and support the following four proposals. And the expected outcome is that you have to fulfill every year. And because our code base is C++, so you will need to know how to write a C++ program. And because all of these are related to the Wasm proposal, so if you have some background, or you can get to study the Wasm spec, they will be fine and will help you to get into the situation easily. And of course, everything you write have to submit with Git. So you have to know how to use Git and use GitHub to submit your pull request. Yeah. And you will find that in this project idea, we don't have any, requirement for the pretext, because we believe that is a project idea that you need to know, you have to read the code, and you have to read the spec, and then do the implementation. So it's just an implementation job, but you will spend lots of time to, study the spec. So that's why we don't have some, pretest. Everything you do is to provide your GitHub profile in your resume. And I believe there are some other requirements is set on the, the mentorship website, such as the cover letter. So you have to fulfill that, then that's fine. Okay, this is the first, project idea. Then let's go to the second one. The second one is that we are applying the FASR, and some, researchers are running their FASR on our code base, and you will find at least lots of issues here, and most of them are related to, the WASI file system, such as you can find the FD represent the file descriptor, and lots of the WASI file system issue. So that's why I list lots of things here. But at the end, we only require you to fix or determine 6% of land. Land is is covered in this project idea. So if you want to apply this one, and please make sure that you have some skill in C++, because our code base is C++, and you will need to know the details, especially the WASI spec, because most of them, if related to the WASI file system, then you will have to read the spec and figure it out. Also, we do have pretest or some ask question is here. You have to write a planning to talk about how or what you are going to finish this project idea, because there's a lot of issues. So you have to do some planning to say, hey, which one should be in what order, and when you plan to do it or do that. Yeah, so please make sure after you submit your application on the on the mentorship website, you have to submit your proposal here. Yeah, so that's the second one. And The third one is that we are going to, dig into the LLM and to figure out if we can, build the deep understanding of a GitHub repository, especially, to help us to know the knowledge in such a repository. And you have to create an LLM app for that. So there are some expected output here. You can just read by yourself. But I believe this is most relevant thing you may need to know is this project we are using Rust. And I believe this slide should be deleted because Rust is required. And you will use LlamaEdge to do the application. And if you are familiar with ChatGPT or how LLM works, will be great. And also because you need to build knowledge base, that's why you have to need to know the RAG process. It will help you to understand what is the goal of this project idea and how it actually works. And yeah, so that's the recommend skill of this project. And please make sure that you have, we have a pretest. So you have to finish this pretest to ensure that at least you have the, basic qualification for applying this one. And the fourth one is that we are going to create a Wasm-based applications for financial analysis. So that's the same, here are some, expect output. You can just read through it. And this one is very interesting is that you can use Python or use Rust to do this project idea. And I believe some of you know that in our previous mentorship, most of our projects are related to Rust or C++. I believe if now you have the Python one, then it's very good to know to use it. Yeah. So now they are almost the same. You have to handle the knowledge base, so you have to know the RAG process. And if you have any, background of the LLM, that would be great. And don't forget to finish the pretest here. And I believe that's all. And the last thing I want to talk about is that the mentorship, the timeline. Just make sure that you have your, application submitted by the due date. If you, if you exceed the deadline, then we will no longer accept that. Yeah. So please take your time, and we are welcome for your, contribution and applications. Thank you.
All right, Haidai. So yeah, that's yeah. So those three opportunities, I think some of them are harder. That's requires more stronger expertise. Some of them are, I think, easier, and I would say I wouldn't say require less, but require, I think, broader expertise in terms of combining different data sources and standard state of art applications. But some of them are really deep, hardcore project at the infrastructure level. So yeah, that's I think that's all we have. We're gonna hang around here for another couple of minutes in case you guys have questions. And so if you have questions, you can you can raise your hand or just ask in the chat. And yeah, so I guess this relates to my demo, right? Do we need to have middleware to handle the tool or the LM figures which tool call if there's multiple tools? Also, what are the criteria of selecting a mentee? So there's a bunch of questions, right? So yes, so I wouldn't call it middleware, but it's the kind, right? So the large language model requires, so the way it works is that you describe what are the tools available. So, so we described to the model that we have the create task, get tasks, delete task, update task. Those are the functions. That's tools that's available for the large language model to use, right? So we put that in what we call system prompt, which is a background prompt for the large language model. And when the large language model returns as you saw, the tool section, it chose one of the tools from the available tools that we gave it, right? So as you can see, it's for the first three questions that we want to add a to-do item. So it chose the create task tool, and then it chose the get tasks to get a complete list and send it back to us, right? So, so it would, the large language model is responsible for detecting what the user wants and then selecting a tool. And once it selects a tool and sends the result back, and send it back, the client I don't know if it's called middleware or not, but it's in our case, it's a Python application that we are running. That receives that and then executes the tool and gets the results and then send the result back to the large language model. And then, based on that result, it generates a natural language response, right? So that's basically the entire workflow of this. And so the next question is, how do we select mentees? We typically get a lot of applications, so we look at your background and, your resume. And I believe in the application process, you can also include a cover letter, which basically would describe, why you find this exciting. And we also have pre-tests. The pre-tests typically ask you to set up something just to make sure that, you have the right hardware and you have the skills to at least set up the tools, right? So those are, I think, pretty simple tasks, and that's really mandatory. That's because if you can't do those, then there's virtually no chance you'll be able to finish that internship, right? So we select based on those criteria. We look, so there's a hard, if you don't do the pre-qualification test, then the chance of being selected is really, really low. I don't think, we have ever selected someone who hasn't done the test. But, assuming that you have successfully done that, either by replying to the, GitHub repository by showing off your work, or, by replying the issue, or, sending your result privately, or sending your result in your cover letter, right? So there's multiple ways you can discuss, how did you finish the pre-test. And then it's basically depends on the resume and the cover letter. Yeah. So Haidai, do you have anything to add?
Nope. And I found no, I don't have anything to add. Yeah. Sorry.
Okay. Yeah. So then the second question is, we don't really provide feedbacks, that's before the deadline, because it would be somewhat unfair to other people or other students who may apply a little late, right? That's and that's also why Haidai mentioned earlier that it's not really us, but the Linux Foundation strongly discourage people to get in touch with mentors privately, because it's really difficult to be fair to everybody if someone just have a private conversation and get some information that's not public, right? So we like Haidai said, we don't reply to private emails for that reason, because whenever we reply to you, it might have private information that other people should know about that as well, right? So it's so we don't really give before the deadline, we don't really give individualized feedback. Sorry about that. All right. It looks, oh, okay. There's another one. Okay, great. Thanks. Yeah, so I guess that's all, right? That's so if you have other questions or comments, just go ahead and yeah, okay. So leave a comment at the issue. I think that's the most effective way because everybody sees that, So it's yeah. And if there are things that you want, let us know privately. So for instance, if you have done the pre-test in a way that you don't want other people to see how you did, put that in your cover letter. That's we read the resume and the cover letter from all the applicants. Okay. Okay. All right. So I guess that's it. Thank you so much, and I'll see you next week. All right.